Hey guys, this is Professor Janacek, and I want to talk about taking derivatives of functions in several variables. We call these partial derivatives. Now, just as a review, we've got the definition of a derivative in just a single variable. That was the limit as h approaches 0 of the difference quotient. So it's the limit of the difference quotient. That's the formal definition of the derivative. And you can see that our definition for a partial derivative is very, very similar. We've still got the limit as h approaches 0 of f of a plus h comma b minus f of a b over h. So you'll notice sort of like we had x plus h here, we have a plus h here. That is the partial derivative with respect to x. Notice the subscript tells me which variable I'm taking the derivative with respect to. The second one, we have the partial derivative with respect to y. You'll notice in this case, I'm adding that little bit of h to the y value. In this case, that's b. So just make sure you know how to read these. This first one, again, is the partial derivative. Of f with respect to x. Of course, this is at the point AB. This one, however, is the partial derivative of f with respect to y. Evaluated, of course, at the point AB. Now, just so you understand what this kind of means, we can say this first one is the rate of change. Remember, the derivative is a rate of change, so this is the rate of change. But this is, since it's with respect to x, it's when y does not change. So y is like a constant here. Whereas in this one, it's the rate of change when x does not change. So x is constant when we're taking the partial derivative with respect to y. These are both considered the slope of traces. Actually, we should say slopes of traces. This gives us the slope values of those traces, if you remember what a trace is on those graphs. I want to talk a little bit about notation. The notation for the first partial derivative, as we've seen, we put a subscript there just after our function name to identify the first partial derivative, and there are a couple other ways of writing this. We can use this notation. It looks something like that, almost a fancy looking d, evaluated again at the point AB. Remember, you can also make that a little clearer. That evaluating at AB, I could use this notation. The first partial with respect to y, notice we'll be changing that y, making that a y in the denominator. And again, you could write it with the vertical line being evaluated at y. So let me just make sure you understand what's going on here. Remember that we had the notation, well, this, of course, we say is d, and we had the notation dy dx. These are what we call ordinary derivatives. However, this notation, again, it's kind of a swirly D. You can say partial D. And sometimes you'll also hear del. That's how that's sometimes read. And so del x, del y, del x. That would be a partial derivative. All right, so now we kind of know how to read these. So we have the partial derivative of f with respect to x, the partial derivative of f with respect to y. Remember, f is defined on both x and y. Now, because we have two variables, when we take a second derivative, we can actually take the second derivative with respect to either x or y on each of those partials. So for this partial, I can take the derivative with respect to x or y. And for this other first partial, I can take the derivative with respect to either x or y. So let's take a look at what that looks like. One way of writing it is, instead of putting those parentheses, is just to keep those in order. The first partial with respect to x, the second partial also with respect to x. And so that is the derivative with respect to x of the derivative of f with respect to x. So we could write that as the second derivative of f with respect to x both times. Similarly for y, we could write this as second partial derivative of y with respect to y both times. So that's the derivative with respect to y of the derivative of f with respect to y, or the second derivative of f with respect to y both times. Now, what about if I have the derivative of x the first time, but with respect to y, the derivative with respect to x the first time, with respect to y the second time? Well, again, the subscript notation is f sub x y. And so what this means is we're going to take the derivative, the partial derivative, with respect to y of the partial derivative of f with respect to x. So notice how this at this point the notation gets turned around. This is saying I'm going to take the derivative with respect to x first, and then with respect to y. Another way of writing this is it's the second derivative of f with respect to y after x. So again, make sure you notice first x, that's actually here in the back now, and then the y, the second one, is written first. Whew, that gets a little confusing, I realize. Let's see if we can figure out what it looks like if we take the derivative, the first derivative with respect to y and the second derivative with respect to x. So again, the subscript is just y followed by x, the order that we're going to take those derivatives. So it's the partial derivative of, with respect to x, of the partial derivative of f with respect to y. Again, notice first is y, then x. I could also say this is the second derivative of f with respect to x after y. Now I understand things, again, this is in the reverse order, first y, then x. That does get a little confusing. So that's why I do realize that a lot of people like to use this notation, and that is fine. That makes it a lot clearer in many cases. So there you go. That is our notation and the idea behind a partial derivative. We'll take a look at some examples here in just a bit. Enjoy!